So I'm going to talk about Fury, and in particular the roadmap to its release, which is coming very soon now. I'm just working on the final one or two features over the next week or so. And if you follow me on Twitter, you will see I published a roadmap for Fury quite recently. And what I'm going to do today is talk through some of the features that are in Fury to be released this month, to be released in 3 months in the second milestone, in 6 months in the third milestone, and I will speculate about when the first version will be released. A little bit about myself. I'm Jon Pretty. I've been working with Scala for about 15 years. I have a company, Propensive, and we specialize in training, which basically means I haven't been very busy with paid work this year, which has meant that I've had maybe more focus on open source. But hopefully next year I'll be doing more training, visiting more companies, and teaching more Scala. I also work on Fury with Vertislab, who you maybe know have recently become the stewards and maintainers of the Scala 3 compiler, which is a huge thing for them, and I'm really happy that they're working with me on Fury. They're supporting my development. And what I hope this will mean over the coming months and years is that Fury and the Scala 3 compiler will go very well together as a build tool and a language. So I'll start by giving a very high-level overview of the roadmap towards version 1.0. I will start with this month. Towards the end of this month, I will release Milestone 1 called Alecto. 3 months later, Megera, and then Tisiphone. Maybe wonder where those come from, those names. If you Google for them, you'll find out. I'll leave that as an exercise for the viewers. And then the aim is to have version 1.0, which let's say the goal is for it to be as stable and as reliable and as dependable as SPT was when it went to version 1.0. That's my kind of benchmark of a good place to make the jump from sub 1 version numbers to 1.0. So let's talk about what is coming very soon. And this will be the first version of Fury that I'm actually intending to suggest people try on projects. It will have the capability of building most Scala projects. So any build that is currently represented by SBT or Ant or Maven as well should be representable in Fury by this version. There's no major gaps, and I will recommend it to the point of it's an opportunity to play around with it. I would not suggest that any major organization that depends on Scala adopts Fury on the release of Alecto. But I would welcome people to try it out as something that is approaching a release, 1.0 release in a year or so. So the first feature I'm going to speak about is publishing, not binaries in the sense that we've seen publishing to Maven Central or Artifactory with the ecosystem we're familiar with, but publishing builds definitions to a new website called vent.dev. You can vent your Fury. That's the pun there, and it'll be possible to use a single command in Fury. So you type in a command that will share your build with the rest of the world. It'll give you the address immediately that you can then share with people, and they'll be able to access the build. There's no delay of waiting for it to percolate through a system. It becomes available immediately. Builds can also be tagged with a major and a minor version, And there's an interesting feature I'm going to experiment with. It may not make it as far as version 1.0, but I will allow people to put an expiry date on a build, which is an indication of their confidence in that build. Now that's very experimental. I don't know if that will work as a way of allowing maintainers to give the indication about their belief in the build they've written. But at the moment, any build can be published and it remains on Maven Central, or any binary can be published and remains on Maven Central, for example, for all eternity. We'll experiment with that. We'll see if people make quick publishes for 7 days and then they republish again for a year, or whether everybody just defaults to infinite time or 10 years or something. This is something I would like to test out in the wild. Authentication for publishing will be with GitHub using OAuth, and the idea is that you will publish things at the same group name as your GitHub organization, or actually any group on GitHub that you are contributing to. So I will publish things as propensive / some project name, but I could also, for example, publish things to other organizations, VertusLab / something, if I wanted to. Now this all works because Fury has a concept of hierarchical builds. You define what is called a layer in Fury, and a layer contains projects and also imports of other layers, which makes available any projects defined in the imported layer in your own layer. So you can build layers from existing layers. You can compose them into what is effectively a tree, a hierarchy. And what this enables is the ability to very easily modify not just your own build, not just the project you're working on, but to have equal access, equal ability to maintain and modify any other build that you depend on. And because Fury uses sources for builds, that means you can change the exact git commit, git hash you're using. You can depend on a different version of the Scala compiler. You can tweak things if you want. You can make all sorts of changes to the full hierarchy that you wouldn't otherwise be able to do without cloning the repository, building it, publishing it, re-importing it, and going through quite a lot of steps that are necessary to do just mere experimentation with builds. So I hope this particular feature will become an enabler for everybody to have the ability to maintain not just their own project, but anything they depend upon, and to contribute that back. I've said for a long time that there's too much burden on the few people who are responsible for maintaining projects. And anything that can be done to relieve that burden, to mean that there isn't pressure from an entire industry on one person who maintains a key project like Scala test or Scala.js, that would be spread over everybody. Anybody would be able to make the tweak that's necessary to bump a version or change a binary or add a compiler flag when it's compiled. And because Fury builds everything from sources, the compiler is checking the consistency. It's checking that the source code or the compiled code links correctly simply by virtue of being built with the same version. It's known that it's built with the same version that its dependency is built with. We have a consistent snapshot of the entire ecosystem built from source that is checked by the compiler, and we don't have this risk of conflicting binaries and attempts to migrate one or the other that potentially result in a class not found or a method not found error. And there's also the ability to update the imports automatically. So if you're importing, for example, a type level layer, which contains projects like shapeless and cats, and that is versioned with a major and a minor version number, you can automatically upgrade minor version numbers and you can incrementally upgrade major versions. The idea is that if it's a major breaking change, that's published as a new major version, and all of the people who use that will make the migration step by step. Bump up the version, test it, check everything works, bump it again until you get to the most recent version, assuming that's what you want to do. In the case of minor versions, the idea is that they will not break anything and you can upgrade them automatically. So there's a little bit of experimentation with dynamics here, the dynamics and workflow of different users in the ecosystem, both the consumers of libraries and the producers. Different feature now of the next release of Fury. It will support Scala.js. So when you compile code, you have the option of not only compiling it, getting the errors if there are any, but if there aren't, exporting the resultant jar file, not as a jar file, but as a .js file. And that is something that I think is very easy to set up and works very well. I've actually used it to build my first Scala.js project. So I've used Scala.js without using SBT, and it works. And I've written less JavaScript this year, which makes me happy. And in theory, we can do the same thing for Scala native. It hasn't been done yet, but the architecture of Scala.js and Scala native is very, very similar. And it's quite exciting. If people have been following Scala native, they may have noticed there's been a little bit of a lull for a year or two in activity and progress. That through work between Virtus Lab and the Scala Center is going to accelerate over the next few months, and I'm excited that there will be Scala native for Scala 2.12 and 2.13 coming soon, and I hope next year for Scala 3. So Scala native running on Scala 3 is on the agenda, and we could see Scala actually being compiled for embedded applications. Scala on Raspberry Pi would be possible. This is all exciting stuff. Fury will support that. It will be a build tool that can produce native binaries through Scala native. Now, when you have a large and potentially complex graph of dependencies, as most projects do, often tangled and potentially with conflicts or potentially with details that are inconsistent on different subgraphs. So let me explain that a little bit better. When you depend on one project, let's say you depend on project A and you depend on project B, and both A and B depend on a third project, C. And unfortunately, they depend on slightly different versions of C, which means that when Fury comes to build the graph, the thing that is called C, the node that represents C in the order of the build process, is inconsistent. And this is a problem, because either we need two separate Cs, one for A and one for B, or we need to somehow unify them. And it's the unification process which is one of the newest features in this first milestone of Fury. So I've been working on this both for the purposes of providing this feature for the entire ecosystem of potential users, but also because I've been using Fury to develop Fury, and from time to time I have these graph conflicts, and I have issues where I'm depending on Magnolia. I mean, it's my own library, but that doesn't mean I completely avoid the problems of different dependencies on different versions of Magnolia. And because I've got a lot of people who are I'm very happy are contributing to Magnolia, the version is changing every few weeks or so. What this means is that when I publish a library like Gastronomy, which uses Magnolia to generate hashes, or Mutatus, which uses Magnolia to access cloud database, these potentially depend on different versions of Magnolia. Now, by default, this is a conflict and Fury will stop. But it's a conflict in order to make you aware of the problem. The solutions are actually often very, very simple. So we could, for example, have a layer that contains the Magnolia project, the Magnolia layer. Now that layer will be imported by different projects. Mutatus will import it, Gastronomy will import it. But maybe they import different versions. So there's a command that will identify the different versions of the same import and will allow you to unify them. It might be that we have source dependencies on Magnolia, source dependencies which point to a particular commit hash of a Git repository, but we have two different versions in use somewhere in the tree, and we want to unify those. We have commands now for modifying the entire tree to change one commit to another, to unify them, so that we have consistency on the source code that's used throughout the entire build to compile the project. The same can be done with project definitions. Project definitions themselves are defined as details like the name of the project, the modules within it, and these are the things that have dependencies between them, which make up part of the graph. And excuse me. And these may have subtle differences which effectively mean that the build is doing something different. It's potentially producing a different kind of artifact as a result. These can be unified as well. We also have binaries. I'll talk a little bit about binaries later because I've introduced a new conflict resolution system for binaries. But there is the option to universally update these if you want to start using a different version of I don't know, JSON, for example. You can specify that, and it means that you can upgrade everything that has a dependency on that Java binary. You can update the version number. And what this means is that it becomes possible to I've said here, recompile the entire ecosystem, but maintain the entire ecosystem. More to the point, everybody can change anything that they depend upon because our dependencies are data, and the data depends on sources, and the tool we use has access to all of that very easily. And in theory, we would no longer need to wait potentially many months for the right person, the key person in the ecosystem to make the updates. We would just do it ourselves. We can either do it ourselves and keep it private, or we can do it ourselves and offer it back to the community by publishing it on venting our Fury. I'm not sure how long that pun will bring a smile to anyone's face. Anyhow, let's talk about binaries then. So I use Corsair, which is a fantastic command line tool and also library for working with binaries and dependencies. And Corsair is used to download binaries, but also to resolve them. Now, if you have a small collection of binary dependencies in a project, those may themselves have transitive dependencies on other binaries. And Corsair is able to work out that those transitive dependencies exist, and will transitive conflicts potentially exist, and will automatically bump up the version number of one or the other dependencies to make sure that everything comes back in a consistent class path. Now that's quite nice. I'm always a little bit nervous about changing a binary for one that was compiled for a different version of the source code, compiled from a different version of the source code, and expecting that to still work with downstream dependencies that were built against the earlier version. Usually things are fine. Usually it requires the authors to be very careful about binary compatibility, about methods being added, methods being removed, details changing in the parameters, and mistakes are very easy to make. So I'm nervous that this happens, and the consequence is a runtime error rather than a compile time error. So what I want to do is make that a compile time error. Now, nevertheless, binaries do work reasonably well, and if you are depending on binaries instead of sources, Corsair will be used to resolve all of these. Now that's great. You can define a project with its binaries, and Corsair will resolve everything, and it'll come up with a class path for you. It will run the compilation, and it'll produce a new jar file at the end. That is what Fury does in a simple case. Now, in an earlier version of Fury, if I had two independent projects, maybe written by different people with different sets of binaries, or maybe overlapping sets of binaries, and I depended on both of those, Fury would need to find a coherent, consistent class path for both of those projects. Now, the problem is when you're developing this project or this project, I hope you can see my video because I'm holding my hands up. If you're developing one project or the other project, you run all your tests and you do all your checks against the set of binaries that was resolved when you were thinking about that project in isolation. But when you bring those two projects together as dependencies to a third project, at that point, we could actually have Corsair resolve a different set of binaries. And this, I think, is problematic. So what I did in a later version of Fury is I added an invariant that the set of dependencies that is resolved, binary dependencies, should I say, for a project in isolation, when you are developing just that project without consideration for your downstream users, the set of binaries that is resolved must be consistent with the set of binaries that would be resolved for a downstream project which depends on it. Now that might seem a little bit strange. What that means is that if you are working on the downstream project, you get the benefit that those two libraries that you depend upon should compose perfectly, because there will be no automatic updating or upgrading of binaries in order to do that. The burden that Fury shifts upon you now as the developer is that if you do have that situation, you maybe have to go and manually add binaries to the dependencies directly. Now, this wasn't possible before because you didn't have control over them. But because of the structure of layers, the hierarchical nature of them, Fury allows you to just modify those. You can just add those binaries. You can do the checks that you need to do for that project in isolation, safe in the knowledge that it will be run with exactly the same class path. At least all the relevant parts of the class path will be exactly the same for that project in isolation as they would be when you merge it with others or compose it with others. You don't have to share those changes. The maybe impact on the the dynamic within the Scala ecosystem, where certain maybe sort of coherency around one binary version or another, and attention to migrating that, whereas individual users may spend more time making the updates they need for their own projects, but they have complete control over it. So the benefit you get, which is the last point here, is that the compositionality of dependencies becomes easier to reason about. We can think of a project which depends on two others in many ways as a composition of those two, rather than some sort of amalgamation of them that maybe changes details of them and potentially breaks them in some way. Now, the final or second to last feature in this release of Fury that I'm going to talk about is something called workspaces. And I have to say this probably isn't very exciting to people who aren't already using Fury, because it's more a description of how a particular set of tasks is implemented in Fury, rather than any magic feature that it's relevant to Fury's model for how things works, rather than general new abilities for things you couldn't do before. But Fury produces graphs of modules, and those modules will generally produce class files, Java class files, and then they get those class files are added to the class path for downstream modules in the graph. Some modules in Fury may, in addition to doing compilation, they may run some code. So run the main method of an application. Now that means you can do anything you like, or anything you can do in Java, at least, in an application module. So you can generate source code. You can connect to a database if you want, and download a database schema and generate source code from that. You can print some random output to the screen if you want to. All of these are possible with application modules. That is fine, but we often want we want to generate artifacts that we can use later. We want to generate, for example, source files, and then have them available to us in other places, in other modules. And workspaces are the means of doing this. All it is a directory that is created and set up before the application module runs, into which certain artifacts can be placed. Now that can include most obviously jar files, either fat jars or merely the class files from the most recent compilation of a module. It could include the source files that were from another used in another project. Those, instead of jar files, we could export JavaScript files. We could export binaries in a world where Scala Native runs on Fury. Or it could be other artifacts like Maven Central, Maven metadata with hashes and so on, or other stuff as well. That then becomes available for the application module to use in whatever way it sees as appropriate, and to produce its own files, just leave them in the workspace at the end. And having produced some output in that workspace, that is then available to be used later. So you could, for example, have an application module which produces a tar file by including a jar file, including a couple of other scripts from other places, and just leaves that tar file in the workspace, which then makes it available to be exported. That is basically all there is to it. Like I said, it's not particularly exciting. It is just one model for implementing things that could have been implemented in different ways in a different framework. And I will finish off talking about the next release, the Alecto Milestone 1 release, by speaking about layer diffs. So layers, I can't remember if I mentioned this particular talk, but I've mentioned it before. Layers are pure data. Each one is an instance of an ADT in Scala. There's a case class structure which defines a layer. All of the projects it contains, all of the imports, all of the modules, all of the dependencies between them, all of the binaries they refer to. It's just a value in Fury, which means that you can examine them very easily. It's much more easy to examine whether two layers are different or the same when they're just data and they don't contain any code. So we can do a diff, and Fury will give you a list of the differences between the layers. This is particularly useful when you're doing a Git merge and two different branches have modified the layer. And a line diff is not a line diff on the layer definitions is not suitable for us. Our data structure is more complicated than that. We can't represent it in a form that allows that line diff to be useful or for a merge to be safe. So Fury will identify if a Git repository has conflicts which need to be merged, and you run Fury layer diff, and it will tell you what the differences are. And I tweeted an example of this recently, and you can then go and pick and choose which of those to merge. And in the future, it might be as simple as running an auto merge command, which will take the changes, as long as those changes in each branch that we're trying to merge together haven't don't conflict, then that automatic merge should be possible. That is all that is coming in Milestone 1. I think that the set of features I've talked about there is maybe sort of ignores the fundamental features that allow you to write builds and focuses maybe more on the issues that I've been looking at recently and that have been taking up my time with Fury. So if you don't know much about the model and design of Fury, and you're listening to what I've just said, and that sounds like a random collection of features. So I talk about compiling Scala.js. I didn't talk about compiling the JVM, but it does that. It has all of these, all of the standard features that have been there for the last couple of years. I would say check out one of my other talks on Fury. I've done a lot. When a project is taking close to 3 years, there's a lot of time for giving talks. So I've spoken a lot about this in the past, and the talks are out there in various places. And those are a better place to find out more about the design of Fury. So I'm going to head now into the future, things which I've done maybe experiments with, I've speculated about, I've come up with designs in my head, but which I haven't got working yet. And Magira is another feature release. One of the things I've really wanted to do for the users of Fury, who are not me and the people I work with most closely on Fury, are Bash and Fish users. And currently we support ZSH, and you get really good tab completions with ZSH. You can type a command, you press tab, and it gives you all of the sensible suggestions for what that particular parameter might be. And this is really nice to use to the extent that if you don't have it, it can be actually quite painful to use Fury. So tab completions are hugely beneficial for anyone using it. I don't know if anyone uses Git very much without tab completion, but I think anyone who does use tab completion in Git would certainly miss it if it went away. It's a similar story with Fury. I can actually go further with ZSH's support for tab completion. There's an opportunity here, and in particular, if you're filling in a parameter value, like specifying a dependency, you can press tab, and at the moment it will just offer you the values. It doesn't give you any explanation as to what the values are. It doesn't tell you where the dependency comes from, which layer it was defined in. This is all information that could be presented to the user and provide a really nice interactive user experience through tab completion. There's also the opportunity for better online help. So when you're typing a command, a -- help parameter would literally be very helpful, and that's something that I will intend to add. Binary publishing is a feature that is repeatedly asked for. I think it's got so much easier over the years, and I've been able to do it quite regularly recently with Maven Central, when for years I had trouble. But it's still, I think, harder than it should be. And this is something which sadly I don't care about too much for my own purposes, because I'm focusing on a post-binary world where we all publish source builds, and this is my dream or my fantasy. Whereas the reality is that most people who work on libraries are still publishing binaries. So it is a necessary feature, and it does get. I keep kicking this particular can down the road. Megera is the release that will finally add binary publishing, and it will do all the work of generating the metadata and also capturing it. So when you specify a build for when you're specifying an SPT build, for example, you have to include this little chunk of XML that contains details like the author and so on. I will update Fury's interface to make sure that those things are asked for through the user interface in a more natural way than including a little chunk of XML. And obviously it will do the generation of checksums as well. So this particular slide may cause fear, concern, excitement. Have I got some questions? I do have a couple of questions from Phil. I'm sorry I didn't notice these sooner. Phil says, could I say a little bit about why I decided to make a new build tool? And a follow-up question, what do you think of Tasty for library publishing? So the first question, Phil, I think I will try to answer at the end. And I will mention, because I've been talking a lot about source builds and binary builds, and Tasty is kind of a halfway house between those two, providing most of the benefits. I think Tasty is going to improve things a lot, and it's going to improve the binary publishing world. I think not to the extent that Fury will be obviated. I certainly hope not. But it will be an improvement for having more certainty that when we compose, or when we try to compile code against dependencies, we know more information about those dependencies, or the compiler, should I say, knows more information about those dependencies than it previously did. And that will go a long way to improving the situation. I still think there is a need for tooling to help resolve. I think there's still a gap in that even with Tasty, you have. You may have two different libraries pre-compiled against different versions of a third dependency, and that needs to be resolved by recompilation, which means updating the source code, maybe making changes. This is still difficult to do in a binary world, even with Tasty. So it does remain to be seen. I think Tasty is going to make things a lot safer, but it's not a complete solution to everything that Fury is proposing. So while I've been talking about that, the Docker slide has been on the screen, and you may have been reading the bullet points here. This next version will allow you to use Docker to run parts of your build. So the capabilities of Java can be a little bit limited. You can't do whilst Java is largely will largely work the same on different computer systems. If you for example execute a system process, like I'll use the example of tar again because you want to run tar, and the parameters to tar happen to be some either the POSIX version or the BSD version don't quite match up. Your code is not cross-platform, or maybe you're using a different version of tar, and it might be that Docker can actually provide you with a more consistent environment in which you can run some non-Java parts of your build. It might be that, for example, so I have some websites and I publish them on Google Cloud Platform, and I use the gcloud command line tool to upload and make changes to that. Now, that happens to work fine on my computer, and luckily I'm the only person who publishes these websites, but I can't give that build to somebody else and expect it to work if they don't have the gcloud tool installed. But if I wrote a Docker file that sets up a simple environment based on like a vanilla operating system that has nothing but gcloud installed, I could use that to publish. And it would take a couple of minutes for the Docker container to run and update everything on the cloud server, and then it would exit, and the build could continue. What Fury will do, and this is the design I have, you'll be able to specify images as a module type in Docker. Those are images in the sense of the Docker images, in which you'll be able to specify a Docker file that creates an image that is runnable as a container. And then later you can specify a container module type, which will actually run that container. And the interaction between those Docker module types and Fury is that the image is created from a workspace in which we can export things like jar files, source files, any kind of standard details that can be extracted from earlier steps in the build. The Docker image will be created from that workspace, and it can be used later as a container. You can instantiate and run a new container from that. And if you want additional items to be available in that running container, they will be available through, again, a workspace, this directory containing whatever resources you would like to have available, as a mounted directory within the container. So this gives both the generation of the image and the running of that image as a container. It gives you access to the parts of Fury that, or the artifacts from Fury that you need to run that. And it does it with minimal detail of, there's no complex plugin API that you have to adhere to. Literally, you mount a directory that contains stuff. You expect stuff to be there. Or you write a Docker file that depends on files being in a certain location. That will enable a lot of more complex builds that do things that can't currently be done with Fury. Binary shading will be a new feature in Magira. The ability to automatically shade binaries, for example, when you have dependencies on conflicting projects, and they're so different, those two conflicting versions, that you can't update the code or you can't make the changes you need to make to unify the version they're using. But thankfully, those two versions don't need to interact with each other. So one example might be a JSON library whose API changed between version 1 and version 2 and uses the same package name, a lot of the same class names, which means version 1 and version 2 simply cannot coexist on the same class path. Shading allows our two projects which depend on the two different versions of this JSON library to be compiled as normal, but afterwards they will be, every reference to one particular version will have the class names, particularly the package names, the package they're in, rewritten in the bytecode to something different. And that would then allow them to coexist on the same class path. And the goal is that this will be very simple to do in Fury. You'll be able to specify that there is this dependency, but the dependency will be shaded on a particular package name or with a particular prefix. And this will just add an additional step in the compilation process where Fury will do that rewrite using standard open source tools for doing that. And it will allow builds to exist, or allow the composition of dependencies to happen where it wouldn't previously have been possible. Improved task management. This little feature is more of an admission that there are some serious problems with Fury's task and thread management at the moment. If you cancel a build, it doesn't actually cancel, it continues compiling until it finishes, which is far from ideal, but not really a showstopper. But it does sometimes result in shutting down Fury because it runs as a daemon. Shutting down doesn't work as it should. And we also don't have a lot of visibility of some long-running tasks, such as downloads and other services Fury uses. So this needs an overhaul. The schedule for that is to implement that in the second milestone. Now the final, I think the final, maybe not the final. No, second to last big new feature coming before the end of the year will be layer variations. So the ability to specify a layer which contains projects and modules, but to have certain variations available, distributed with the layer, but available as options that can be turned on or off. For example, the choice between Scala 2.12, which is maybe your default, and Scala 2.13. And you'll be able to import that layer with the 2.13 flag on. So these will be variations that allow you to make these tweaks. And a variation or a tweak to a layer is a change to some part of the data structure because it is just data. So we could, for example, tweak the reference to the Scala compiler, tweak the import of the layer that imports Scala to use a different version. That's just one small difference in the definition of the build that changes the Scala compiler that's used. But those variations can also be things like including more output or from the compiler. You may want additional logging included, or linting, or details like this. These can all be made available as tweaks or variations to the build, which turns them on or turns them off, or works in some other way. I've given some examples here, different Scala versions. You could also include optional dependencies. You could optionally include the tests as part of the build. Maybe you really want to run the tests as well as just doing the compilation. And what's nice is that these variations can be combined. You could, for example, change the Scala version and change the dependencies. And the way the build is defined allows that to work. Fury could generate a compatibility matrix. So as long as a variation is not changing details of the build that another variation is changing as well, that compatibility matrix would allow those two variations, those two tweaks to coexist. I guess I don't really know SBT very well, but I guess the equivalent in SBT would be plugins that modify the build graph and then modify it again with a different plugin. It's providing the same sort of functionality. How am I doing for time? I've got 5 minutes left. So I'm going to speak about distributed caching very fast. If you're working in a work group with other people, you might like to share things you've already compiled which they need. If everybody's using source dependencies and something changes and you have to recompile the whole world, that can be quite slow. But if your work group has to compile any particular thing only once and thereafter can share that, this will make builds faster. And that's work in progress. That will potentially be very helpful for avoiding very long compilations. Milestone 3, we're looking at end of Q1 next year. I'm working with Virtus Lab at the moment. They develop metals, the metals for VS Code integration. And what we would like to do is build a graphical user interface for working with Fury. So from Fury's point of view, it's running as a daemon. It would actually expose a REST API that would allow you to send requests to it. But we could build an extension for VS Code that would use that REST API, and will in fact use that REST API to query and actually mutate builds from a plugin rather than using the command line. I really like command lines as an interaction, as a way of interacting with a tool, but other people would maybe prefer a graphical user interface. We could also provide a Fuse user interface. This is maybe a bit more niche, but why not mount a layer with its project and all of its content as a directory? That will, if you've used Fuse already, that will maybe be exciting, or you may actually feel that's a little bit irrelevant. And finally, the big feature that I have planned for Milestone 3 will be the ability to distribute builds. So not just reusing previously built artifacts that other people on their computers have built, but to actually spawn builds on multiple computers, multiple trusted machines. So establishing links with other computers on your local area network, other people you work with. I guess the idea of a local area network in a pandemic maybe isn't quite the same as it was when everybody used to work in the same office, but this isn't going to be ready until March next year anyway, so we might not we won't miss it until then. Hopefully we'll be back in offices again, but the ability to spawn a build, which is maybe a large build, and have other computers on your network do some of the work for you. This is the big feature in Milestone 3. I won't elaborate on that too much further. Hi, Alejandro. Welcome. Just seen you arrive. And that is the end of my slides, and I finish with version 1.0, hopefully in summer 2021. And I don't know if I missed any further questions.
You answered those two ones, and I think you answered those both in the Q&A, didn't you?
I didn't actually answer the first question, which was why did I decide to write a new build tool. I have talked about this on a few occasions, but the motivation was a lack of understanding on my part of the existing build tooling. And I have a bit of a habit of developing things as developing libraries and tools as a means of learning them. This was actually maybe a little bit deeper with Fury and build tooling. I really didn't understand how SBT worked. I had lots of trouble trying to get my head around the details, things like scopes, and at the same time, other people did invest time in understanding SBT. And I guess I am really just lazy. I was too lazy to understand, devote the time to understanding SBT. And instead, I started developing it at a time when projects like Bloop became available. Bloop gave me the ability to dispatch compile jobs to the compiler, which would very quickly do the compilation and give me results back, which simplified my task enormously. And I believed it was possible to get a build tool up and running in about a year. And we're in year 3 now. But the scope of Fury has increased. The design has changed in that time. The proof that it can do useful things and work well as an environment in which to develop has been proven to me. But at the same time, I've been adding features. A lot of the things here, almost all of the things I've talked about today weren't really envisaged at the time I was setting out. So I don't know if that fully answers the question. I actually started development on a flight from Boston to somewhere in Europe on my way back from a conference when I was at 40,000 feet and had no internet connection. SBT wasn't working and I couldn't fix it. And I had plans of, because I generally tend to be quite productive on flights. This hasn't been a productive year, but when I'm taking long flights, I tend to just sit with my laptop. I don't watch any movies. I don't move at all. I just get on with things, and there's no distractions from the internet. And I make good progress generally. And I couldn't do this. I couldn't make any progress on this thing because it wouldn't build, and I was really annoyed by it. So I thought, okay, I've got 10 hours. I'll try and write a build tool, and that was how it started.